Okay, let's start it. Let's get started. All right, so yeah, it's already week 4. We talk a lot about ADT, examples of ADT. As what I hope is I want you to learn the concept of the object through the ADT, the abstraction, the abstract data type. Actually, every time when you are trying to making something a class, it's a process of abstraction. Okay, so I just want you to get a sense of how do you do abstractions through the ADT. But now, since this week, let's come back to the object-oriented design. Okay, so today what I'm going to talk about first is the discussion on is and has those two relationships. Remember we talked about this two relationship? Is has generalization and aggregation, or inheritance and aggregation. Right? What's the difference? Can any one of you specify a little bit? What is what is has what is aggregation? What is the inheritance? Come on, you know that, right? But is has that's actually very clear about the situation, right? Okay, let's start from is Can any one of you give me an example of is a relationship? I am a SUV is a car, yes. Yeah, that's is a. SUV can be a subclass. Car vehicle can be a superclass, right? And how about has a?
Car has a door.
Car has wheels, engine, door. Yeah, car has doors. Car has wheels, engines. Yes. Yeah, that has a relation. Okay. So that's the what difference definition. Okay. All right. So, but is the relation of inheritance. Inheritance like a kids get something from the parents. Okay, and it's kind of the feature of one of the good feature about object-oriented design. Okay, so there are some misunderstanding there. Think inheritance is seen as good, so the more I use it, the better my code will be. Is that true? Who agrees with this statement? Because yeah, we know that inheritance is a good feature of object-oriented, and it's a very important feature of object-oriented design. But the more we use it, the better our code will be. Is this true? Whoa, it's raining really heavy there. Is it true? No, yeah. Well, yeah. So from what I'm, yeah, okay. So you might think, yeah. Well, it sounds like, well, it sounds like not true. Okay, but the reason we don't know, right? Okay, so let me talk about that. All right. Well, that looks like tornado, is it? Yeah. So heavy. You hear the sound? Oh, let me double check. We don't have the warning. No, we don't. No, we don't. No, we don't. Okay, good. Yep. Okay. let's go back to our class. Yeah. All right. So inheritance is not a relation between different objects. There's no. Well, this is not a relation between objects. Yes. That's a relation between the classes. Okay. I can give you an example of why we say that it's not always true to use the inheritance. Okay. For example, we have a okay. Let's say we have a student class. Okay. We have a student class, and then we have another class called we have another type of student. We have a type of student called full-time student. And another class, well, another type of student called part-time. Okay. How do we define the classes? This relation of these classes. Probably inheritance, right? Because student, full-time student is maybe a type of student, right? Part-time student is a type of student, right? Okay, let's do this. So I kind of have this inheritance. Like it is a full-time student is a student. Part-time student is a student. Okay. Now I want you to specify another thing. Now we have a full-time student, part-time student, and then with the growth, the development of the university, okay, we have a student that has a scholarship, have the financial aid, has scholarship. Students who do not have the scholarship, okay, so where shall we specify them?
The student.
In the student?
Yeah,
Within the student. Okay.
Over within full-time student.
Yeah. So full-time student can be student with the scholarship or not. Part-time student can also be the student with scholarship or without scholarship. Okay. Yeah. So where do we put them?
Student.
Okay. Let's say if we put them in a student, all right. So if we put them in student, one of the problem is, well, there's a potential problem. So full-time student and part-time student, they have different requirements for the scholarship, and they should have received different amount of scholarship because they take different classes, right? And also, while the eligibility is different, maybe we require 3.0 GPA for full-time, maybe a little bit lower for part-time. That's possible, right? Okay. So, but if we define the scholarship with its eligibility, its amount, all in this student class, so which one should we go? Full-time or part-time eligibility?
Because we can overlap the method.
What's that?
We can overlap the method in student.
We can overload. Yes, we can override.
Yeah.
We can override the method. Yeah, but if we override the method,
That's double work.
yeah, what is the meaning of the inheritance here? If we inherited everything, but we override that, that's actually a waste of work, right? So do we have any other possible design of that? Say we want to do the scholarship.
So they go
Using
short-term
inheritance.
scholarship.
And non-scholarship. Non-scholarship, okay. Yeah, these two features. Yeah, so we want to make modification to the system, and we have these two features. So is there any other better design to just put them in the student? Because if you put them student, yeah, you have to put the attributes into student, and in all the inherited method, you have to override them. That's actually a lot of work. It doesn't save up efforts of modifying the system, changing the system, right? So any other good way to do it?
Areas interfaces.
Mm-hmm.
Use interfaces.
User interfaces.
I mean,
Use interface.
well, it's still double. It's the same thing because it's still double inheritance. Yeah.
Okay, now let's go back to this principle here. Continue reading, see what can we do. Okay, so the problem here is first the dimension changed. A dimension is added on scholarship, not on scholarship. We would need to have additional subclasses. In this manner, we need additional subclasses like full-time student with scholarship, full-time student without scholarship, part-time student with scholarship, part-time student without scholarship. So it's going to be very difficult and a lot of work, and create extra classes which increase the chances of getting errors, bugs. Okay. And another problem here it mentioned is a full-time student decide to go to school part-time. Yeah. A full-time student decide to go to school part-time. The problem here is they may have to change its class, right? Assume you are now a full-time student. Okay. So we can just say full-time student A. We give a new value, your name, to full-time student. Okay. But when you decide to change to part-time, what's gonna happen? We need to create a new class for you, right? And discard the old class, because your object is created from a full-time student. If you want to change, we need to create another part-time student class object from the part-time student class for you, right? So these two problems implies that they might not be a good solution here. Using inheritances might not be a good solution because it creates a lot of overhead. Although it makes some sense that because full-time student is a type of student, part-time student is a type of student, we inherit them, right? It sounds like okay, but if you give it a second thought, may not be that reasonable, right? So do you suggest any other design strategy? just not using maybe we just not using the inheritance. Okay.
Full-time and part-time to become an attribute of the student.
Yeah, exactly. Let's try that. Okay. Let's see. Let me find that. Okay. Yes. Okay. Now let's see if we want to make the full-time and part-time student as an attribute of a student class, right? So what actually here happened is we have two problems, right? First is full-time decide to go part-time. You don't have to change your class. You don't have to create a new object. You can just adjust the value of that attribute. You change it from full-time to part-time, right? So the design becomes this. And it's a student class, right? And we have a lot of attributes and operation for every class. So there is an attribution called type, or attributes called part-time, full-time, maybe status. Maybe it's just a boolean, right? Like if it's true, then it's full-time. If it's false, then it's part-time. Something like that, right? Or enum, maybe specify if it's 1 or 2, it's full-time or part-time, right? So that's going to be easier, right? So this is something that implies inheritance is not always good, right? Okay, and for this design, how about scholarship and non-scholarship?
Sometimes we make it become an attribute of the student.
Yeah, we make it become an attribute. Yes, we can do that. Yeah. And yeah, that's actually similar to, yeah, I will have another solution, but I can talk about that later. Let's go from here now. Yeah, so right now a good solution is we put both the full-time, part-time, and the scholarship, non-scholarship all as attributes. That's a good solution. Yes, that is a solution better than the inheritance. So I'm specifying this example just to tell you that inheritance is not always good. Okay. All right, then let's talk about yeah, inheritance should be used to separate the commonality from specifics only. Okay, not well, but for this situation, it's better to use the attributes. And also, when you use inheritance, important thing is you do not actually put restrictions on your super class. Like there are some functionalities the super class can have, but you do not have. This is kind of violate that rule, right? Like if you your student class has the ability to, well, has the attributes of the options of scholarship, but you have some certain of sub student class who do not eligible for scholarship at all. Okay, there are some type of student who is not eligible for scholarship. Okay, yeah, like maybe contract student the company pays for that, then they do not go for the scholarship, right? So contract student, let's say contract student. If you have a scholarship attributes there, or if you have some functionalities of getting scholarship in the superclass of student, and then in the contract student subclass, you are restricting this scholarship. That implies this could not be a good design. This may not be a good design. Okay, so subclass should not restrict the superclass, put restriction on superclass, constraints on superclass. Also, it's because of the polymorphism, right? Like polymorphism, like if I'm a student, I should be able to use all the functionalities of a student. So I'm not sure. Okay, I have a student type, and I have a student object created from that class. Okay, but so whenever I use it, I may call it student.get scholarship. However, if you specify that student as the contract student who cannot get scholarship, so there will be error there, right? Because polymorphism, that means you can use the student, the superclass, the student object. You can use that reference to any type of student. You should be able to do that. You should be able to refer that object to full-time, part-time, and contract. And they should have the common behaviors, which is called through that reference. Okay. I mean, something like this. Okay. Student A, right? So that's a reference. Right now it's empty. Okay, so now we can get some A. We give some value. We have some other functions to get student. Okay, now we have a student in this A, right? But we do not know what type of student it is. Is it full-time, part-time? We don't know. But somehow, if we have another thing called A dot get scholarship, right? So if we have a program that has this 3 sentences in a row, this 3 statement in a row, yeah, that tells us we should make every subclass of student A have the ability to get scholarship. We shouldn't post any constraints in any of the subclass of the student A. So that's one of the principle you kind of want to follow. Well, the principle here, I want you to follow, but if you violate this principle, your code may not have the syntax error. It will go through, it may compile, it may run eventually, but it just violates the design principles here, and it gives you the possibility of getting trouble in the future. Okay. So like this, when we design that full-time, part-time, yeah, this all work. But in the future, when the school grows bigger, we have a lot of company contract student here, and we didn't notice we have this thing here, then problem may occur, right? Okay. Then let's talk about aggregation. So aggregation should be used to show composite relations, right? Composite relations. So we can test for aggregation. Aggregation just has a relation. Just okay. So is the face part of used to describe the relationship? Like is my hand part of me? I think so, right? Are some operations on the whole automatically apply to its parts? Like if I went home, did my hand go home? Right? If I go home, my hand will also go home, right? If I go up to upstairs, my hand follows me. Yeah. Okay, the third one is there an intrinsic asymmetry to the relations where one class is subroutine to the other? Like my hand is part of me, but you cannot say I am a part of my hand, right? Okay. So it's a subroutine of the other. Yeah. So the sense of aggregate is to collect the parts so that the cardinality is greater than 1 should typically be used. Like just the relation, just 1 to many, many to many, this kind of relation. So like 2 hands, something like that. Well, I have 2 hands. Oh, I may have somebody may have 3. So, yeah. Okay. So typically used here. So that's about aggregation. So that should be simple to understand, right? Can anyone of you give me an example of aggregation? Except the hand. Just do not think about human, think about something else. How about cars? How about wheels, doors, window. Yeah, some of them may not have window, but most of them have window, right? Yeah. Okay. Okay. And also here are some rules for the generalization. Okay. So given that class A with subclasses B and C, class A is a superclass, B and C is the subclasses. Okay. Do subclass B and C make sense as specializations with the problem domain? This is important here. Within the problem domain, okay, because sometimes it makes sense with the problem domain. B and C is a subclass of A, but in another domain, maybe in the school domain, okay, you want the teacher and the staff and to be the subclass of employees, right? But in a company, why do you think a teacher and why do you think teacher is the subclass of employee? It's not. If we change the problem domain, right? In the school domain, yes, teacher is employee, but in company they do not have a teacher. And teacher may be some external class that provides some consulting service to that company, but they're not employee, right? They do not have that. While their employee has the ability to get through payroll, get paid, but if a consulting service, it may get the pay through another channel, right? So within the domain is important, okay? Not like teacher is always the subclass of employee, okay? All right, second, does the system need to recognize the difference between a B and a C? How are the system's responsibility for the specialization different? Like well, we just want to define the necessity of a B and C, right? Like a full-time and part-time student, well, this necessary to distinguish part-time and full-time. Okay, so yeah, so that's why we think that they might be they might be subclasses. But here the difference is well, that's only meet this criteria, but some other criteria make the full-time, part-time not eligible for subclasses. But here we want to recognize, do we really want those 2 subclasses? Are they necessary? Maybe we can just do everything with 1 class, right? Like do we want to distinguish, well, we have teacher subclass and the professor subclass? May or may not, right? Maybe they are just performing the same thing. in some problem domain. Okay, so you want to find out the necessity, if they're necessary to do this. So will there be inheritance? Do some attributes and a method apply to all A and then specialized into attributes that apply to only B and others that apply to only C? Okay, that's the situation we just mentioned, right? So this means if we have a superclass A, subclass B and C, we have a part of the behavior of A that is applied to B and part of behavior that is applied to C. Okay, that implies this may not be a good design. Okay, this may not be a good design. Right, like let's still do this employee, teacher, and other stuff. Okay, so if the employee has the functionality of teaching class, giving lectures, is it a good design? No, because only the teacher will use that functionality, but the staff probably will not. The other staff will probably not use that functionalities. Okay. So, yeah. Next one, if the only distinction between B and C is the type, like a full-time, part-time, you probably want to use the attributes enumeration on the superclass. Yeah, you do not need that inheritance. And if the subclass adds no attribute or method, it is not needed. Do you agree? Adds no attributes or methods, it is not needed. Yeah. So that means actually the principle does not favor a lot on override some functionalities. So when you inherit something, you just assume that the behavior you inherited, you will do that behavior. But you have some of your additional behaviors you want to add into that. But it does not encourage you to do a lot of override. But sometimes we might want to do the override, yes. We might override some functionalities in some scenarios. But that's actually is not favored by the pure OO principle there. I'm not saying you cannot do the override, just it's not favored in the principle. It may lead to some of the it violate a little bit of the principle, but it then may lead to some problem in future. Yeah, when you change a lot with the system. Yeah. And last one is do not use generalization just to factor out a common attributes if there's no generalization specialization in the domain. Keep the model easy to understand. Yeah. I mean, they have to make sense, right? If they have something in common, you think, okay, I can make a car a subclass of airplane because they have something in common. They all travel, they are something like that. So do not do that. That's actually violating the rule. Well, you do not. That's not a inheritance. That doesn't make sense, and that does not fit the rule of the maybe the rule of the physics, the category in general. Okay, so that will lead to a problem. It's your understanding to the code, right? Because if you see, okay, airplane, car, a subclass of airplane, so it may lead to confusion of the person who is trying to understand the system, understand the code, right? So and maybe you make this decision today just to not want to rewrite the code to make it simple, but in the future, okay, when you maintain the code, you will feel the pain, right? So that's yeah, that's the thing. Yeah. Okay, and let's go back here. Student, full-time, part-time, scholarship, non-scholarship. Okay. Well, so scholarship and non-scholarship. Let's assume that scholarship and non-scholarship, they have a different some of behaviors there, because non-scholarship, scholarship, they pay through different channel, right? So yeah, one of the option is we put them into the class here as an attribute. But another option, can we use something else? Because there are a lot of changes. Full-time and part-time is the attribute. That's pretty simple. You're full-time, you're part-time. Okay. But scholarship and non-scholarship, that changes a lot, because you may change from one to another. You may also have a scholarship. The eligibility every year, it may change, and the amount can be you can get from scholarship change, and the money available change. A lot of changes there. So do we want to put them as an attribute? Yeah, that work. Is there any other way to make it?
You might make it become a class, like a class of scholarship.
Yeah.
A relationship between student and scholarship.
Yeah, let's see if we can do it this way. Okay, how do you think about this? Scholarship specification. Okay, let's make this a class. Okay, since this is actually basically attributes, if you have scholarship or not, it is kind of an attributes of student. So actually attributes, remember that if it's attributes actually naturally it comes with has a relationship. So we can do this. And let's not use this, just to avoid confusion. Student has a scholarship specification class. Okay, and then we may try to have this do you think this is a good design? This is the inheritance. So why don't you think this is a good design?
We should like a status of the scholarship as an attribute of the scholarship specification class.
An attribute of scholarship, but they have different behaviors. Yeah, they have different behaviors. So if you specify, and they do not seem to have a lot of common behaviors. There's still scholarship and non-scholarship, right? Right. If there are a lot of difference, probably they should be within the same class, because you have to if they do not have different, if they do not have a something common, you have to specify basically every method for different attributes. So that may create a problem, right? So still, the scholarship specification is an attribute of student, okay? But we can make scholarship and non-scholarship a subclass of scholarship specification, so that in each one of them we can like just specifying different behaviors for the scholarship specification. Yeah. Specification may not have a lot of common operations here. It could have nothing here in the operation here as the scholarship specification. However, this just helps you to just separate the difference, like a separate of concern. You put a concern about scholarship into one class, and the concern about non-scholarship to another class, and then the scholarship specification as an attribute of the student help you to organize this scholarship and non-scholarship. This way you can both make them happen here. So yeah, and it does not actually violate the principles here. So if you do not if you remove a specification from the student, do you remove this as well? Yes, right. Like if you remove this class, if the student do not have the scholarship specification anymore, you can just remove this class, right? But however, if you define the behavior of scholarship and non-scholarship within this student class, when you're trying to remove this specification in the future, everyone becomes scholarship, right? You have to go into that class, method by method, try to dig out the non-scholarship thing, remove that. That's a lot of work. But here it's just going to be easy. We can just get rid of this class, then everything works, right? So that's the idea of using is has a and separation of concern. Yes. Yeah. Okay. Cool. Now let's that's the has and is. Let's talk about our homework. So a lot of students is asking. Vehicle modeling homework. So basically, it asks you to complete the vehicle model, just like what we did to the students. This thing. Okay. Use the similar modeling notation, and please label your relations. Okay. So include what I want to see is 3 levels of generalization, which is inheritance, which is a relationship. Okay, no problem with this part, right? And it's 3 levels of aggregation of one class. Okay, just this 3 levels. I mean, not like I have a hand, a eye, 2 eyes, a nose, right? That's 3 aggregation, but 3 levels means I have a hand, right? I have a hand. My hand has a finger. Finger, right? Has a finger. A finger has nails, something like that. So that's called 3 levels. Okay. 3 is one example of classification. what was include what was inherited. Okay, so so it just means an instance, an object, because this is the level of a vehicle, maybe vehicle, SUV, sedan, and then you specify which category is your car belongs to. Maybe your car is the instance of SUV, something like that. And you should also be able to specify what is inherited, like in the car class, in the vehicle class. You have some attributes, functionalities there, like I'm not sure. Just, what all the vehicle has in common? A vehicle has in common wheels.
Colors.
Yeah, wheels. Okay, and then SUV has something special. What's so special about SUV? It could be some additional attributes, maybe. Four-wheel drive system, suspension system, but that's all come from the vehicle. Okay, so
The distance from the ground.
okay, sorry, a vehicle, it may okay. Vehicle may not have an engine. Okay, because it can be an actual vehicle you're driving, or it can be a vehicle that just human drive, or you push the vehicle, or be a wagon that's the horse is using as the power. Okay, so vehicle, maybe wheels, and then you inherit from another level. It's the vehicles with engine. Okay, you inherited the engine from that level. Then you inherited something special about your SUV from the third level. So that you show that your specific SUV, like a CRV, Honda CRV, has the engine, has the wheel from the vehicle, has an engine from the second level, and then it has something special about the SUV from the third level. Okay, do you understand that part? Like, let me give you the example. Yes. Vehicle. Maybe gas engine vehicle. Here we have cost driven by just a wagon. do not have an engine. Okay. And then we have a SUV. Here we have a electric engine, right? It can be a subclass of the engine vehicle. So SUV, and there are a lot of other things I won't model here. Okay, specify one of the instance is your CRV here. Your CRV as an instance, okay, as an instance of the SUV, and you need to specify what you get from vehicle. You inherited attributes inherited from vehicle engine vehicle, gas engine vehicle, and SUV. Okay, this is what I mean. I want you to specify what you inherited from each level. Okay, maybe behaviors or attributes, but just what you inherited from each level. Okay, all right. And also at least one attribute and one method per class level. You don't have to show the inheritance method attributes. Yeah. So like here, every level I want you to specify an attributes and a behavior. Yeah. So what you do is you can use hand drawing or use any of the tool you like. Okay, like the class name here, attributes, and method or behaviors. Okay, use this type of thing to represent a class, like a class diagram of UML, if you know that. All right, and I want you to make the vehicle as the root, like what I did here. And pick any class for the aggregation. Yeah, and for is make the arrow pointing up to the superclass, like what I did here. Engine vehicle pointing to the vehicle. Okay, so subclass pointing to superclass. And for has use a line off to the side, not an arrow. And after you complete your model using your instance, please list all the inherited attributes and the method for that instance. Okay, clear about this, the assignment? Great. Yeah, so I got some requests from students to explain this modeling homework, so That's the explanation of it. And this is a partial example of the answer of the class. You may start from here, or you can have your own design to specify the levels. Maybe this is not a good one. Just model it. Okay, there's no problem domain. Just I want you to get the sense of excuse me. I want you to have a sense of how to use the inheritance, how to use the has a relation, is a relation, and how do you generalization things, like getting clear about the levels of the classes and the relation between classes and objects. Okay.
Professor, do we have to use different shape of the arrow, like different type of arrows to describe inheritance relationship and aggregation relationship, or we just need to put like has is next to the arrow?
Okay, so this pointing is a subclass pointing to superclass. That's for is a.
Yeah,
and has a, you can just use a line, just specify has a. That's fine. You don't need an arrow. Okay.
Oh, just the line.
Yeah. Just use a line. Yeah. Okay. And I only specified is a here. I didn't specify the has a. Okay. And also I extended the deadline to I think September 16.
That's nice.
Yeah, 16. So it's gonna be the Monday. Yes, next Monday. Yeah. So that's all for today. Any questions? Question. Regarding anything, maybe schedule or anything. Okay, that's great. All right. Well, thank you very much for your time today, and have a nice evening.